13.3. Graph the function f of x equals the absolute value of x on the set of axes below. State the domain and range of the function. All right, so I'm just going to use the table we did in the previous problem. There's no point doing the same work again. So I've got the coordinate -2, 2, -1, 1. All right, so -2, 2, -1, 1. I see the coordinate 0, 0 here. 1, 1, and 2, 2. So I'm going to connect my dots here. And I notice I've got a slope here of -1. Making sure I put arrows at the end here. And then here I've got a slope of up 1 over 1. That'll be a slope of 1. Both have the same y-intercept of the origin, or 0. Put an arrow there as well. All right, state the domain and range of the function. Well, domain refers to all the possible x values. So if I go all the way over here, that would be going all the way towards -infinity, right? That arrow never stops. So my lower bound is -infinity. Right, and I use the soft bracket here because I don't want to include -infinity. It's exclusive. Then when I go all the way to the right side, I'm going towards positive infinity on this x-axis. Right, even these axes extend forever. So that's one way I can write it. I can also write it as -infinity. Oh, that's an 8. -infinity is less than x, is less than infinity. And then if I wanted to write it in set notation, I would say that x belongs to the set of real numbers. Real numbers just means every single number possible. This symbol just means belongs to. It's really the Greek letter epsilon, but in a college level class you might see it like this. So right, you could say that it's, or yeah, you can say that. It's real numbers. I guess really, sorry. We could say the domain is that, and then you could also say x just belongs to the real numbers. That's saying the set includes all the real numbers and x belongs to it. They mean the same thing. Different college professors might show it differently. Depends on who you have. All right, range, right? These are all the possible y values. So I'm going to first look for the lowest one. And I can see that that right here is 0. And it's a filled-in circle, so we're going to include 0. All right, as I go up all the way, I'm going towards infinity on my y-axis, so that's my upper bound. I could also write it as a inequality. X is greater than or equal to 0, or x is, can't equal infinity. X is less than infinity. All right, in set notation, we could say that the domain of a function is x belonging to the real numbers. Well, actually, I guess you would say here, you would say x is the real numbers, given that x is greater than or equal to 0, because it can't be negative real numbers. Or they might say x belongs to the real number set greater than or equal to 0. I've seen professors do that as well. All right, that's just for part A. All right, and guys, again, if these are tripping up this last row, don't worry about it. I just, I would feel bad if I didn't show you that. But really, the first 2 rows are the important ones. Right, we can't reach -infinity. We can't reach positive infinity. So I'm using soft brackets. I can't equal -infinity, so it's just greater than. And I can't equal positive infinity, so it's just less than. I can equal 0, it's my lowest point, so that's a bracket like that. Inclusive bracket. And this parentheses, I can never reach infinity, so we don't include that point. Right, then the inequalities refer to the same. All right, on the set of axes below, graph the function y equals absolute value of x plus 1. So the first thing I'm going to do is make a table. X and y. So I'm going to really make it a little bit larger. Actually, I'm going to make it -3, -2, -1, 0, 1, 2, and 3. All right, state the range. So if I plug negative 3 in, I get the absolute value of negative 3 plus 1, which is really just the absolute value of negative 2, which equals 2. So negative 3, comma 2 is the first point I'm going to graph. All right, then just keep doing the same thing. Negative 2 plus 1 is equal to the absolute value of negative 1, which is really just equal to 1. So negative 3 down to negative 2, and that's 1. And I can actually tell right now that if we've got a linear function here, right, I could probably predict the next point's going to be right here, but let's just test it. All right, negative 1 plus 1 is absolute value of 0, which is just 0. All right, so now I got 3 points. And remember, this is always going to be either 0 or a positive number, my absolute value. All right, so I plug in 0 there. 0 plus 1 is equal to absolute value of 1, which is just equal to 1. So now we can see, oh, now we're bouncing back up. We've reached the point where the distance from 0 can be 0. And now we're bouncing back up. All right, so I'm also going to fill in these points because I know it's a linear function, slope of 1. So I can just do that. All right, state the range of the function. Well, it's actually going to be the same as our range before. Right, it's the same exact minimum and maximum. Right, even though it looks like it's lower here, it's going on for infinity. So my range I can just write the exact same way, starting at 0. I did that twice, ending at infinity. All right, starting at 0, we can equal 0. We cannot equal infinity. And then we can write our range as a set of real numbers, given that y, sorry, we're talking about our range now, so y. Oop, made that mistake twice. Talking about the range, so I gotta use y here. That y is greater than or equal to 0. All right, state the domain over which the function is increasing. So right now it's going down, right? It's a negative slope, so it's considered decreasing. And it doesn't start increasing until right here. Now, this is where you may have math teachers who disagree. If you wrote either one on the test, either one, I think people would agree with you either way. So we see at this point right here, x equals negative 1. It's sort of in between going down and going up. So some people would say, oh, since it's in between, I would say that it's starting at negative 1 exclusive and then going up to infinity. But I'm not going to include negative 1 because it's not increasing at that point. If you wrote with a hard bracket, negative 1 infinity, I would give you full credit. I think you have a valid point. But, you know, that's different math teachers will tell you different things. Whenever math teachers do that, I'm just sort of like, you know, can't you both be right? I don't know. It seems kind of ridiculous to argue about something like that. All right, but we can also write it in as an inequality. So negative 1 is less than y. Oh, no, we're talking about domain. It's less than x. It's less than infinity. Or if you're of this school of thought, right there. So maybe if you pick one. Do you think the function is increasing at this point? Is it decreasing? Is it neither? Have an opinion. Explain why you think that is. That's interesting to think about. Then we could also write it in set notation. X, the domain is the set of real numbers, given that x is greater than negative 1. Or we could also say x belongs to the set of real numbers greater than negative 1. All right, that's it for 13.3.